So about 6 months ago, I enrolled in a new class in my school called STEM Pathways, in which students got to design and test out a solution or a product that would help solve a global problem within their local area. Now, after some brainstorming and considering all the options, I decided to choose to develop and test out an aerial seedball dispenser that would be able to be fitted on an aircraft used for in-country flights within Kenya. Now, the premise of the idea was to be able to fit something onto an aircraft to be able to be operated by the passenger while the plane flies over rural Kenya or Africa, dispensing seedballs. Going into designing and brainstorming ideas for possible prototypes, the first thing I did was research the seedball and whether or not there were any previous attempts with aerial seedballing. To explain what a seedball is, it's essentially a seed that is encased within a charcoal shell. This allows the seed inside to grow without having to go through the tedious process of actually planting the seedball. Moving on to previous trials, there were attempts to drop seedballs out of a plane through its windows, but people found that it was too hard to push the seedballs outside due to the difference in air pressure. Another complaint was that the wind could cause dust from the seedballs themselves to fly up, disrupting the cabin. So in the end, our extra requirements would be to create an external device that would be on the outside of the plane, as well as one that would be able to dispense the seedballs with ease. To counteract the difficulty with air pressure, we decided to use the Venturi effect. The Venturi effect is basically a principle that uses differences in air pressure to create a suction. By creating constriction for the air to go through, this causes more air to go through the same space at once. This means the air has to move faster through that one point, which causes lower pressure, which in turn causes suction. We would use the suction to negate the previous problems with getting the seed ball out. We also looked at current successful products, one of which was called a Venturi Spreader, that was meant to be fitted on an air tractor. This design would be very similar to what we wanted to do, but on a larger scale, as well as using an internal hopper for storage as opposed to our external storage. Moving on from this, we decided to get a rough prototype together, mainly to test out the Venturi effect, how effective it would be in terms of suction, and whether or not it was really necessary. To do this, we taped together two halves of two balls together. Then we made holes in various points and plugged all but one hole at a time to test the suction using a probe at different points to figure out where we should place the funnel for the suction. At our highest suction point, there was a pressure difference of 1.74 kilopascals. That's over 1,000 newtons of force per meter squared. After we discussed and compiled our data as well as visit a few experts in the field, we decided to go work on our first testable prototype. After we looked at our data and discussed, we decided to work on our first testable prototype. Just as we were beginning to do this, however, we got an email from our friends at Coxwell Gecos. They sent us an aeronautically approved cargo pod for us to modify to become our aerial seedball dispenser. Our general design was to place a funnel here with a large entrance as opposed to a small entrance to create the difference in air pressure required to make the Venturi effect. Then, connecting from the entry point to the funnel to the top of the pod, we would create a tunnel. This tunnel would go down till just above the bomb to create a big enough entrance for the seedballs to come out. Then, in the tunnel, we would fit a blocker. This blocker would be attached to two large heavy-duty rubber bands that we would fit to the tunnel. Then, at one end of the blocker, we would attach a wire with a handle that would go through to the pod, up through to the plane, through to the passenger seat. This means that naturally the blocker is pulled down by the rubber bands, blocking the entrance. Then, the passenger will pull the handle up. This lifts the blocker up, allowing the seed balls to come through. Then, when they are done, the blocker is pulled down by the rubber bands and the hole is closed.
After finishing designing and building the prototype, the final thing that we had to do was to send off our prototype for testing. We did this by sending it off to Coxwell Gecos. They mounted it on their own aircraft, and they sent us this video in response. In the following video that they sent, you can clearly see the seedballs coming out, quite rapidly in fact. And yeah, that's pretty much how far I got in the STEM pathways this year. Um, Overall, I'm pretty happy with the final product that we were able to come up with. Um, I think it worked successfully for what it was meant to do, um, and if I were to proceed this further, I would further talk to Coastal Gecos, and see any improvements that they could think of. Personally, I would try to make the handle easier to pull because I remember when I tried it out, it was pretty hard to pull it up, and it was pretty stiff. So I think I would make that a bit easier. Otherwise, yeah, I'm pretty happy. And overall, with STEM Pathways this year, it's been a huge learning experience from the beginning. From thinking of problems to solve, thinking, and then from then on thinking of possible solutions, designing prototypes to help figure out data. Um, with the bottle prototype that we did, and then also going out into the actual field and talking to experts. I went to Tropic Airco, an air transport company here in Kenya, and that was a huge, massive experience for me. And talking to the engineers and pretty much, yeah, it was just an overall great learning experience for me. And